Welcome back, guys. My name still remains Messi Bumi. So I'm still your chemistry and mathematics teacher. So please do more to subscribe, to share our videos. So this evening we'll be treating calculus. Some of the newbies and the stellites, especially in the SS classes, have been complaining about calculus. They're finding it difficult. So I deemed it fit to at least share more knowledge about it. Let's So calculus, differentiation. You know, when it comes to differentiation, everybody's so familiar with it that when we talk about differentiating s squared, we say dy over the s will give you 2x. We're familiar with this. This is the very simplest stage of differentiation. I also want to introduce to us differentiating using the first principle. Most times, when you calculate like this, it is not sometimes acceptable, most especially when you're asked to use the first principle. So how does the first principle work? Let's go. Now the first principle works like this. For instance, let's write out some examples. When you're asked to differentiate with, So when I write WRT, let's note that that is with respect to. So with respect to x, let's differentiate the following. We have 3x squared minus x plus 5. We also have y is equal to x plus 1 squared. Yeah. So I've just given two examples each on every step, on every terms that is used in differentiation, in differential calculus. That's what you also call it. So how does the first principle work? The first thing you do is to increase your y. The y does it by the increment, then you add your dy. And that's why we have, since our y is equal to 3x squared minus x plus 5. Normally, when you're asked to do this in your normal simplest differentiation, the next thing you do is your 3x squared becomes 6x, and your x becomes 1. Exactly. But most times we'll be asked to prove this using the first principle. And that's why if you want to use the first principle, the first thing you do is to make sure your y and your x increase by the y and the x respectively. That is, whenever you find y, you add up dy. So let's go now. So therefore we have y plus dy. Is that clear? Is equal to 3. So anywhere you find your x, you add, and we see that we add x plus the x, and since because it is a square, we put the square into bracket x plus the x plus 5. And so we have y plus the y gives us 3. When you have to open this bracket, we have no time, and I've shown some of the newbies how to do this. But we have, when you open the bracket, you have x squared plus 2x ds plus the x in bracket square. And then minus your x plus the x plus 5. Therefore, we have y plus the x. We open the bracket using the 3. We have 3x squared plus 6x dx plus 3 the x squared. We can also open this, minus x minus the x plus 5. The next thing to do is to subtract y. And let's not forget that the same y is still this. So we subtract y from both sides. And that's where you have y plus the y minus y gives you 3x squared plus 6x dx plus 3 dx squared minus x minus the x plus 5 minus our y is still 3x squared minus s plus 5. Do we understand up to this point? Then this cancels this. We have the y equals 3x squared, we're opening the bracket, minus 5. And because we have similar numbers, similar coefficients here, the next thing to do is to cancel them out. So the 3x squared goes, the minus x goes out, so we'll move to the next stage. So we have dy now becomes 6x dx plus 3 the x squared minus the x. Are we able to cancel them out? Let's try them again. This is what we did. The 3x squared plus the 6x dx plus the 3x squared minus x minus 5 minus 3x squared plus x plus 5. So the next thing to do there, this cancelled out this cancelled out this cancelled out this. So therefore we have 6x dx plus 3x the x squared minus the x. So the next thing we have to do is divide both sides by the x. And that's how we have the y over the x should give us 6x the x over the x plus 3 the x squared over the x minus the x over the x. We cancel them out again. We have this cancelled out this cancelled out one of this, and therefore dy dx therefore becomes 6x plus 3 dx minus 1. When this cancels this, you have 1. And therefore make the make your dx equal to 0. So we have the y over the x should give you 6x plus 3 into 0 minus 1. And therefore, dy over the x simply gives us 6x minus 1. So that is all using the first principle. Shall we also proceed to number 2? Now the number 2 question. Our y is x plus 1 squared. You see, when you see something in square, in a bracket, the next thing is to open up the bracket following the Bodmas rule. So we have my y is the same thing as x plus 1, x plus 1. The next thing to do is to open up the bracket. So my y should give me x squared minus 2x, plus 2x plus 1. Using the first principle, let's not forget. So using the first principle that I said, the next thing you have to do is to make sure there's an increment in your y and your x. And that is only possible when you add up the y, and wherever you find your x, you put in the x. So therefore we have y plus the y should give me x plus the x plus 2 into x plus the x plus 1. I'll follow in. So we have the y plus the y should give me s squared plus 2x dx plus dx squared. I should open up this bracket. I have 2x plus 2dx plus 1. You can even decide to solve it using the normal you know about. And that is your x squared plus your 2x plus 1. And when you have to differentiate this using the normal knowledge you know, you have your 2x plus 2. So this is what we should be getting, even after using the first principle. Let's go. So the next thing to do is to subtract the y from both sides. Let's not forget it is step by step, and that's why it's called the first principle. Then the y plus the y minus y definitely gives me s squared plus 2x dx plus the s squared plus 2x plus 2 dx plus 1 minus the one you open. So right, this cancels out this. So we have a dy gives you s squared plus 2x dx plus the s squared plus 2x plus 2ds plus 1. When you use the minus to open up the bracket, you have minus s squared minus 2x minus 1. Please, let's not make a mistake, because this 2dx looks like this, then you try to add it up. You don't. Why? Because they don't have the same letters. This is x dx and this is ordinary dx. This is s squared and this is ordinary 2x. This is 2x dx and this is ordinary 2x. So let's not do the mistake of adding things up. So the next thing to do is to trash out anything that looks common, anything that cancels out themselves. So we have the 2x is going, the 1 is going, the s squared is going. So we have your dy becomes 2x dx plus the x squared plus 2dx. All following. So the next thing to do now, I'm so sorry my board is small, but I guess we're following everything steps after steps. So the next thing to do is to divide both sides by your dx. And that gives us the y over the x, giving us 2x dx over the x plus the x squared over the x plus 2dx over the x. Am I right? And the next thing is to cancel them out. This remaining your dx, while this cancels this. And then we have the y over the x is 2x plus the x plus 2. The next thing to do is to make your dx limited to 0. And that gives us therefore my dy over the x gives me 2x plus 0 is 2. The y over the x therefore gives me 2x plus 2. The same answer we got when we differentiated it on the simpler form. It's the same thing we got when you also use the first principle. Now, shall we proceed? So the next thing to talk about here is differentiating polynomials. We want to ask, how do you differentiate polynomials when you have 3x cubed minus 4x cubed plus 2x plus 1? How do you differentiate it? The thing to do is to differentiate these numbers one after the other, 10 by 10. Looking at this example, we also differentiate. We're asked to differentiate 3t raised to the power minus 4 minus 4t raised to the power minus 3 plus 2t raised to the power minus 2 minus 1 over t minus 8 with respect to t. We've been doing with respect to x. So let's choose another letter, which is also t. So what to do, like I said earlier, is to differentiate your polynomials each term separately. This 1 over t is the same thing as t raised to the power minus 1. So we can rewrite it to be, the y becomes 3 raised to the power 4 minus 4t raised to the power 3 plus 2t raised to the power 2 minus t raised to the power minus 1, then minus 8. That it may be easy for you to calculate. So the y becomes, when you begin to differentiate, becomes dy over the t. So it becomes, this coming here, just your normal differential calculations without using the first principle. This one is just no polynomial, so you're not using the first principle. You just use the layman knowledge of differentiation. That is, when you have something like 3, 4, when you're differentiating, you have the 4 coming here becoming 4 times 3 raised to the power t, then you minus 1 from your power. That becomes 12t3. So that's the same way you do everything. So we have 12t raised to the power minus 3 minus 12t raised to the power 2 plus 4t minus, this might be giving you issue. So you can put it in bracket, minus 1 or minus t raised to the power minus 2. That is, gives you, when your minus 1 comes down here to multiply your t, and you're also subtracting 1 from your power. So you have minus into bracket minus t minus square, minus 2 rather, raised to the power minus 2 minus 8. So your dy over the t consequently becomes 12 raised to the power 3 cube minus 12t squared plus 4t. When you open this bracket with a minus, you have your plus t raised to the power minus 2. This, when you start differentiating, this becomes 0. Am I correct? So we have your dy over the t. Any number that does not carry anything, any letter that is having also a power, it becomes 0 automatically. So my dy over the t becomes 12t raised to the power minus 3 minus 12t squared plus 4t plus, I might decide that I'm not writing my t as this, I might decide to put it as 1 over t raised to the power 2. That's just it. Differentiating your polynomials. Shall we also look into another polynomial question? Another polynomial question here says 2x minus 1 squared with respect to x. X again. Yeah. So the next thing to do is just to, open the bracket. So when you open the bracket, you have 2x minus 1, 2x minus 1. So your y becomes 4x squared minus 4x plus 1. I just need to go straight to the answer. So I have, so differentiating this becomes the y over the x gives me 8x minus 4 plus 0. Therefore, my differentiating becomes 8x minus 4. That is it. So let me also, build up some of these technical questions by giving us number 3. So These are just the normal, normal simplest questions of calculus. So I promise us by in the next video, moving forward, doing, from simple to complex. See you there. So let's go to number 3. We have differentiate x raised to the power minus 5 minus 3s cubed over x with respect to x. When doing plus, minus, I decided to, use the division sign. So the first thing to do, I don't know if you're very much familiar with the long division method. So that is what you first do. The first thing you do is just divide your equation. If it is divisible, you divide. And that leads you to start differentiating. Yeah. So we use the long division method. Your x is here. Your x raised to the power 5 is in the box. So your x raised to the power 5 divided by your x give you x raised to the power 4. When you multiply this, you still have your x raised to the power 5. You put your minus out. So this one is cancelled out. Remaining your minus 3s cubed. This goes in this to give you minus 3s squared. By the time you bring this again, you have minus 3s cubed, and this gives you 0. So therefore, my y is no longer this. My y is now the answer. That's what I'm differentiating with. So I have x raised to the power 4 minus 3s cubed. Is it technical? It is. That's breaking it down. So if I'm to do this is now a polynomial. So my issue now is to start differentiating it separately. So I have the y over the x to give me 4s cubed minus 9s squared. That's just the answer. Oh, sorry. 3s squared. 3s squared, so I have 6s. Technical. So, let me also give us another example on differentiating polynomials. I have here with me x minus 3 squared over 6x. This is somehow very technical. Why? Because a denominator also has a number of its own. It's just not an ordinary x. So let's see if we can divide it with the long division method. The first thing you do is to open the bracket here. So you have x minus 3 squared should give you x minus 3 into x minus 3. And that gives you s squared minus 6x plus 9. Correct. So, you use your long division method, s squared minus 6x plus 9. Then your 6x is out. If I have to divide this, I have s squared over 6x. It's the same thing as x times x over 6x. So this cancels out. So I have x over 6. So when we multiply this, we still have our x squared. This cancels out, so I have minus 6x plus 9. 6x and 6x will give you minus 1. So when you bring it out again, this one cancels out, so I have 9 here. Then 9 divided by 6x, when you break everything with 3, you have 3 over 2x. 6 plus 3 over 2x. So, consequently, your y becomes, when you also multiply this with this, you have 9. So this is also gone. So consequently, your y becomes this answer. Your y therefore becomes x over 6 minus 1 plus 3 over 2x. The next thing to do is to start differentiating it one after the other. Yeah. So, The y over the s, if I'm to differentiate this, will give you 1, that is, over 6 minus 0. This is also the same thing as, this your 3, 2x is the same thing. It's the same thing as having 3, 2 over 2, x raised to the power minus 1. So this becomes, if I'm to differentiate this becomes, minus 1 times 3 over 2, x raised to the power minus 2. So my dy over the x now gives me 1 over 6 minus 0. If I'm to bring out this, I have minus 3 over 2, x raised to the power minus 2. Right? So automatically, the y over the x becomes 1 over 6 minus 3 over 2, x raised to the power minus 2. Or I can even decide to write it as this. 1 over 6 minus 3 over 2x squared. It's still the same thing. So that leads us forward to another question, and that will just be the end. I just want us to get used to some of the simplest things in differentiation before we move to the complex ones. So the last and the least question here. Let's not forget we're still differentiating polynomials. So we have to differentiate 3x minus 1 into bracket x plus 5 over 2x squared. The first thing to do is to multiply the numerator and then you divide by the denominator. So I have my 3x minus 1 into bracket of x plus 5 over 2x squared. If I'm to open this, I have 3x squared minus 15 plus 15 minus x will give me plus 14x minus 5 over 2x squared. So the next thing I start doing is to divide using the long division. So this divided by this should give me 3 over 2. So when I multiply, it becomes 3x squared. So this is out. So I'm left with 14x minus 5. So if I'm to also divide this, 14x over 2 times x should give me 7 over x. So this is plus 7 over x. When you do this again, you have this. So this is also gone, remaining your minus 5. Apparently, if I'm also to divide this with this, it can be divisible, so I just write it out. If I should multiply again, I have something like this. So it's cancelled out too. So therefore, my y becomes 3 over 2 plus 7 over x minus 5 over 2x squared. So the next thing to do is to start differentiating your polynomials one after the other. So, if I'm to differentiate 3 over 2, I have 0. And if I'm to differentiate 7 over x, 7 over x is the same thing as 7x raised to the power minus 1. So, I have, if I'm to differentiate this, I have minus 7x minus 2. So, differentiating that will give me minus 7x raised to the power minus 2. And if I'm also to differentiate my f, my 5 over 2x, I can also say that it is 5 over 2 raised to the power x minus 2. So if I'm to do this, I'll just have, so if I'm to differentiate this, I should have something like, 5 over 2 times, this minus 2, minus 2x raised to the power minus 3. Yeah, so this becomes the y over the x becomes 0 minus 7x raised to the power minus 2. This apparently cancels out this. The minus multiplies this as minus 5 x raised to minus 3. So therefore, my dy over the x becomes minus 7x raised to minus 2 minus 5x raised to minus 3. So this is the end of today's lecture on differential calculus, beginning from the first principle to differentiating your polynomials. See you in the next video. If you have not subscribed, please subscribe to my YouTube channel and click on the notification bell in case there are new classes where you need to also learn from. Don't forget, I give you solutions to all your challenges in chemistry and mathematics. See you.